This demonstration will show how the calculation and assignment functionality within SAP Profitability and Cost Management can measure carbon impact using the life cycle assessment method. We need to see what the carbon footprint impact is of our bottle of orange juice, broken down by life cycle step. So if we look at this results screen here and go into the summary page, we can see we're looking at the orange juice, and that here we can see a breakdown by life cycle step of the carbon that's produced. So for supply, production, shipping, storage and end of life. And the total amount of carbon here being just over 112 grams of CO2 per litre bottle that is generated. So although this page shows us the amount of carbon, we really need to, in order to try and reduce that, we need to break it down further to do further analysis to understand how we might be able to reduce that figure. So if we move from this screen over through to the results analysis screen, and if we select just the focus, maybe just on the production process, which is probably as a manufacturer where we can have most direct impact within our operational processes, we can see here the various impact of life cycle steps of the product, and also we have it broken down by site and by emissions. So looking at this particular example, we can see that in Seville in particular we have a very high portion of carbon being produced within the production step. And breaking that down further, we can understand that the majority of that is due to the difference, the very high difference in the amount of carbon produced due to electricity consumption as part of the production. So in order to understand that, we maybe need to go back and see why the value is so different between France and Spain. To see that information, we need to go back to our production site data. So selecting total production sites, we can see here that we actually use slightly less electricity in Seville, in Spain, than we do actually in France. But even so, we're still generating more carbon. The other factor that was used for this calculation is the carbon emission factor. So if we choose France and focus on the energy portion of the equation, we can see here that within France, electricity generates 90 grams of CO2 per kilowatt hour. However, changing this to Spain, we can see that it's actually 568 grams of carbon per kilowatt hour, probably due to a difference in the mix and the methods in which electricity is generated between the two countries. France primarily uses nuclear methods to generate electricity, which is obviously far lower in carbon impact, the burning of fossil fuels, which is the primary approach used in Spain for electricity generation. So maybe to assess the impact of changing our approach to this manufacture, we can do a simulation. So if we select simulation and new simulation, you can see here that we've got the current situation, and we can see the actual figures, the figures that we're just looking at, are identical to those in the simulated column here. And there's currently no variance. What we're going to do is we're going to do a new simulation focusing on the 1 litre orange juice in Seville, and we're going to change our energy data. So we're going to move from using standard electricity to using green electricity, which has a lower carbon impact than the use of standard electricity. So we're going to reduce this down from 600,000 to 0 and increase this to 1.1 million. And then if we let the system calculate, we'll see the impact of that change within this particular new simulation. So we can see here that we've had a reduction as a result of that simulation of 29.61 grams of CO2 per unit by, in effect, changing the energy supply within Seville. So if we were to make that change as an organisation, we could see how we would reduce the carbon impact, carbon footprint of the production process for this particular SKU.